Okay, so we're going to go over binomial theorem. Part of binomial theorem is working with Pascal's triangle. So I've kind of started Pascal's triangle. The first row of Pascal's triangle, and we'll go by rows here. This is row 1, row 2, row 3, 4, 5, and we're probably going to need to get up to a couple of these, so we'll actually scroll down to 6, 7, and 8, just so we have an idea. Now, Pascal's triangle, instead of memorizing everything, if you just remember the pattern, you can essentially recreate any row you want. Okay. Now, in Pascal's triangle, if you look back here, this way I have an idea. Okay. What we're doing here is we're taking the first value, 1, and we're continuing it on the outside. It continues all the way down, pretty much like on the edge of the triangle. Okay, all the way down both sides. Then what we do as we get farther down, so row 1 is just the number 1. Row 2 is just the numbers 1 and 1. And then from here is where we get our pattern. We then take our values and we add what's between them. Okay, so 1 still stay on the outside. Well, 1 plus 1 gives us our 2. So the next row is obviously going to be still 1 and 1 on the outside. Okay, so we have 1 and 1. What are the terms inside going to be? That's right, because we're adding 1 and 2. So that gives us 3 and 3. That's the fourth row. So let's go to the fifth row here. We still have 1. What do we get here?
4.
Yep.
6.
Yep.
4.
Good, good. So you understand this pattern. Okay, so we can continue that out. It's going to be 5, 10, 10, 5, 1. We're going to continue this information just because this is actually going to prove to be pretty helpful for us, especially when we go into factoring this. So 15, 20, 15, 6, 1, and then finally the eighth row is 7, 21, 35, 35, 21, 7, 1. Okay, so we've computed a triangle up to about row 8. What do we got here? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 major terms here. Okay, so when we go into the factoring it, they've given us a question. Which one did we want to go through? B? B and C? Okay, so let's kind of jump to a new page here. B. Question B states that, let's read it out. B says y12, hold on, y12, or y to the power of 12, plus 8, y to the power of 9, plus 24, y to the power of 6, plus 32, y cubed, plus 16. Okay, so we're going to use our binomial theorem to get an idea of what this is. Now, we have 1, 2, 3, 4, 5 terms. So we should probably be in the fifth row when going through this. And what we're also going to be looking at, okay, and let's think about this. With our binomial theorem, we know that it usually starts, we have a factor of A plus a factor of B to some exponent, we'll call n, okay? So when we're going through this, we're gonna, first thing we want to check is what row we're in. So we're going to double check this row. Okay, let me just quickly bring something up. Okay, so we're in the right term, but we got to figure out what exponent's going to be in which bracket. So when we're talking about a binomial, that means we technically need 2 terms. Okay, so an A and a B. So that is actually essentially starting in row 1, or sorry, row 2. Okay, this would be a binomial. We have 2 terms here. Okay, and that in this case, our exponent is only going to be a 1 in here. When we expand this to A plus B, our binomial squared, that'll give us the third row. Okay, we'll have A squared, AB, and then B squared is our idea here. Okay, and then from there we have A plus B cubed, then obviously to the power of 4, power of 5, power of 6. So depending on what row we're in, we're essentially one exponent behind that. Okay, so because we said there are 1, 2, 3, 4, 5 terms, that means we're in the fifth row, but that means we're going to be to the fourth exponent. Okay, so we're going to be dropping down 1 exponent because we're working with a binomial when going through this. Okay, so let's jump back to this page. Single page this way. Okay, so like we said, we're in the fifth row here, and that's going to be to the power of 4. So that's the first thing we found out. Our power is going to be to 4. Okay, we have A plus B to the power of 4. That's what we got here. Now the next thing we want to do is we want to focus in on the very first term of the binomial and the very last term of the binomial. Okay. Now we know because this is to the power of 4, if you look at this part here, because this is to the power of 4, we know that our terms are going to both of them be to the power of 4 each. Okay? So, in other words, this term here, to figure out what the original term was, okay, because remember the terms on the outside are going to be just one value, and to figure out what the original value was inside our bracket, this will be our A term, and this will be our B term. We essentially want to take them to the 4th root, because we're to the power of 4. Just like I want to take this to the 4th root, because we're the power of 4. Okay, so I take that first term, and we'll do it in green. We have y12, and we actually want to take it to the 4th root, like we said, because we're to the power of 4 here. So the 4th root of the power of 12 is actually going to be y cubed. Okay, and you can do that in a calculator. Another way you could do this, a radical and an exponent, you can put them together into a fraction and reduce the fraction. Okay, so let's look at the base, y. Now, this exponent would be 12. That would be the top of the fraction. And the power of the radical, whatever the radical is to, we put that on the bottom of the fraction. Okay? Well, what would 12 divided by 4 be?
3.
So 3 cubed will be our original term. That's another way we can solve a radical without using our calculator. Okay? So that's going to give us our A term. That will be our A term in here. So we found another step. We have y cubed. We still are working on B, which is going to be our last term, and we know it's to the power of 4. Well, we're going to do the exact same thing with B. We have the number 16. Now, because this is a number, not a variable to some power, we're actually going to figure out the 4th root of this. Pretty sure it's the number 2. 2 by 2 is 4, by 2 again is 8, by 2 again is 16. Okay? So what that means is the 4th root of 16 is the number 2, which means our B value is going to be the number 2. So the factored form of this is y cubed plus 2 to the power of 4. Okay? And if we were to expand this, which would take quite a bit, or of course we could use our Pascal's triangle to expand it, we would end up here with our 5 terms in the 5th row to the 4th exponent. Okay? So that's the factored form of that binomial.